Hello and welcome to SGN Tech Forum. Today we are going to see how to build a campus EVPN fabric based on Catalyst 9000 switches. As you know, Cisco Catalyst 9000 switches are industry leading hardware and runs state-of-art software called iOS XE, and it uses Cisco proprietary ASIC UADP ASIC. At the same time, VXLAN is a proposed IETF standard that provide greater flexibility than traditional VLANs. It operates as MAC in UDP encapsulation protocol, creating a virtual overlay over an existing layer 3 network. There are various benefits of building underlay overlay architecture because VXLAN allow you to create 16 million tenant workload. It also provide host mobility by using dynamic access gateway, early ARP separation, etc. A lot of benefit. So what we are going to build today, there are various design of EVPN fabric. The one which we are going to focus for campus architecture is bridging and routing. And as you can guess, we will be using bridging to communicate between the same subnet but on two different nodes or uh, throughout the fabric. And we will use routing when we are communicating between two different subnets. That means inter subnet we are going to use routing, within subnet we are going to use bridging. So look at the objective. What is the objective? By the end of this demo, you should be able to configure EVPN fabric layer 2 bridging, and at the same time you should be comfortable configuring layer 3 routing for EVPN fabric. Let's look at our lab setup. As you can see, we have a 4-node topology here. On the top, we have 2 spine nodes, and then we have 2 leaf nodes. And as we go into demo, we will actually add one more leaf here so that you get real-time experience to configure and see things in action. So we have spine and leaf topology. This is a class architecture. That means each leaf has a connection back to spine. However, spines are not connected together, so they act as stateless. Also for underlay, we are running BGP, we are running OSPF for IGP, then we are running BGP for a particular address family communication, and then we are using multicast PIM sparse mode. You can see we have a few VLANs like VLAN 120 for employee, VLAN 180 for IoT, and it is all mapped to VRF campus. Few things to note. Anycast gateway deployed on fabric edges everywhere on leaf 1, leaf 2, and leaf 3. There is a MSDP pairing between spine. Since we are using Anycast RP, it is good to create a MSDP pairing between spines which are actually hosting Anycast RP on them so that the source information is shared across the two spines. Also, we are using multicast for broadcast, unknown unicast, and multicast replication, and this happens in underlay. Now to get started, there are certain prerequisites. That means you are already running an IGP of your choice between spine and leaf, and make sure that all the loopbacks are reachable. Then enable multicast and configure Anycast RP on spine switches. Also configure MSDP between spine switches to share active source information as we discussed. So this is all about underlay. Now VXLAN fabric build steps, that is about overlay. Define a tenant VRF. So you start with your VRF. You can have more than one VRF, but define your tenant VRF on each leaf. Each leaf must have unique RD. So make sure you use a unique RD per leaf switch. Then configure BGP relationship between leaf and spine switches. Here, for to scale purposes, spine can act as a route reflector, and also on leaf, you need to advertise L2 VPN route to the VRF address family. And I'll show you what I mean when we go to configuration. Then to handle bump traffic, choose your replication type. there are two type of replication: ingress replication, which is unicast, and then static replication, multicast static replication, which is obviously multicast. After this, you configure your L2 VNI, that is your VLAN or networks where your users are connecting. Once you have your L2 VNI or VLANs, then map it to the VXLAN encapsulation. So you create your L2 VNI, map it to a VLAN, give it a VXLAN encapsulation, so that this L2 VNI is extended across the leaf switches, multiple leaf switches. Now you want to connect your end hosts. For them, configure a distributed Anycast gateway in form of SVI. However, the interesting thing is all these DACs, they will have the same IP address and one mm, virtual MAC, which is similar across all the leaf nodes. Then you go ahead and configure your L3 VNI, because L3 VNI is needed when you are doing a inter VLAN communication or inter subnet communication. L3 VNI is used to route traffic between different VNIs and subnet. Finally, configure the SVI for L3 VNI and assign it to the tenant VRF. So your uh, L3 VNI is mapped to a VRF. Then create network virtualization endpoint, and it's a logical interface or a tunnel interface that defines or that has L2 VNIs and L3 VNIs mapped underneath. This is where you have your encapsulation and decapsulation of VXLAN happen. Let's look at some of the VXLAN config construct, especially the overlay part of it, one more time. So you need to decide on replication method, and on right side I have some sample config for you. So as you can see, we have replication type static under L2 VPN EVPN. For L2 VNI, there are two parts of it. As you can see, first you have to decide on EVPN instance ID, and this is a VLAN based, and assign an encapsulation. There is only one encapsulation available here, VXLAN. Then you go to your VLAN configuration and how many number of network you have, like 120, 180 in my case. Then you make it or map it to the EVPN instance, what you defined just above there. So there is a VLAN to L2 VNI ID mapping here. That's all about your L2 VNI. For inter VLAN communication, we need L3 VNI, and you can see we have a VLAN just for L3 VNI core VLAN ID, and you're making it part of L3 VNID. Then you need to create an interface so that it can be used for routing. You know that if you are doing a inter VLAN communication, where to send the packet. So for that you need a SVI for L3 VNI, make it part of VRF uh, or the tenant VRF, and then it is a logical interface, so you can use IP unnumbered loopback 0. For VTEP, interface NVE, that's the shorthand for the in this logical interface, NVE1. Here you need to make sure that you say host reachability protocol BGP. So we are using BGP glean information for host reachability, and then map your L2 VNI alongside with the multicast group. So you are saying that this L2 VNI is terminated here, and also it is using one individual multicast group for bum replication, and also map your L3 VNI here in under NVE. Finally, you need to configure Anycast gateway on switches. It's pretty simple. Create a SPI for the VLANs where you have host. Create a MAC address, give it a virtual MAC address, and make sure that this MAC address is repeated everywhere, and give it an IP address, and that IP address is repeated everywhere on all the leaves. And obviously assign it to the part of VRF forwarding. Now we can go to demo, and first we are going to understand how the fabric is built, a working fabric, and then we will add a new leaf so that you get first-hand exposure. Obviously, building a fabric or any network requires some planning. So this is my planning sheet. Let me tell you what all you need. So here you can see I have broken it down into two segments: underlay and overlay. Underlay is for reachability and overlay is for your fabric. So you can see we are using IGP as OSPF, and our subnet is 172.168.0.0.16. This is a supernet actually. Then for BGP, you decide on your AS number. For demo purposes, I'm using 65,000. Then you need couple of loopbacks. So you need loopback 0 on each node, and for that we have chosen 172.168.255.x. So for spine, we are starting from 1, 2, 3, and for leaves, we are going double digit, that means 11, 12, and 13, so on. Also, on spine, you need a few more loopbacks because we are running Anycast RP. So for that, this is my loopback 2, 172.168.255.255. Ignore, please pardon the typo here. So that's my Anycast RP. And then for MSDP peering, we are choosing 172.168.254.x. And last octet is the spine number. So for spine 1, this is going to be 254.1, 254.2 for spine 2. Multicast replication per one subnet per VLAN, as you have seen, we'll use 225.1.1.x. So dot 1 for first VLAN, dot 2 for the second VLAN, and so on. Then you need a point-to-point connectivity for your fabric, and for that we are using a /30 subnet. As you can see, L1S1, that is leaf 1 to spine 1, we are using the first subnet 1.0, then 4.0, and so on. So this is pretty straightforward. Also, leaf get the first IP or the lower IP in the subnet. Now move on to fabric configuration or overlay configuration, and this part will resonate with you if you look at this EVPN config construct. Essentially, all these things we are planning here. So you can see we need a VRF. With VRF, you need RD and RTs. Then you need L3 VNID. You need to decide on what VLAN you are going to use. You need to decide on how your L2 VNID will look like. So we are adopting a scheme that whatever is my VLAN, I'm going to append 10 to that to make it L2 VNID or L3 VNID. So if the VLAN is 110, you can see my L3 VNID is 10, 110. And then you need a dynamic Anycast gateway, which is a SVI uh, for that VLAN, and we are using the first IP address as a gateway. All right, time to visit the lab. Let's go. As you can see, so this is our lab setup. Here you can see we have spine 1, spine 2, leaf 1, leaf 2 connected as a class architecture, and then we have a couple of end hosts connected to them. So first we are going to focus on this fabric, and then we will go to the border leaf and start configuring it as one of the leaf switches and make it part of fabric. All right, so I'm going to minimize this a little bit, and let's start with our spine 01. I think the lab has timed out. Yes. Okay, so one more time, this is our lab. We are going to focus on fabric part first. Make sure that we understand how my underlay looks like, what are the construct we are doing for overlay or the fabric build. Once we understand that, we are going to shift our focus to this border leaf, and Right now, there is no configuration on border leaf other than simple IP address and username, password, etc. We are going to configure underlay and overlay to make it part of Fabric. With that, I'm going to minimize this picture and shift our focus on individual nodes. So for spine, let's first look at some of the configuration or the validation. I would like to show you the IGP first. Show IP OSPF neighbor. You can see we have neighborship with 11, 12, and 13. That is all my leaf switches, leaf 1, leaf 2, and border leaf 3. Also, let me show you the BGP configuration. You can see we have router BGP 6500 and we have three neighbors 11, 12, and 13, but they all are activated only for address family L2 VPN EVPN. So we are not establishing IPv4, regular IPv4 peering, but we are only establishing a particular address family, which is L2 VPN, EVPN in this case. So all the NLRI that will be exchanged is for this address family. Let's see the peering, show BGP, VPN, EVPN summary. You can see we have 11, 12, and 13 as my neighbor. And we are receiving some prefixes from 11 and 12, but no prefixes from 13 because that is the node where there is no overlay configuration. So this is about the IGP configuration, and I want to show MSDP, IP MSDP peer. You can see we have a peering with 254.2, which is spine 2 in this case. All right, that's all about IGP, and show IP VRF. While we are at spine, you can see there is no VRF on spine. Now let's go to leaf 1. So spine configuration is pretty simple. It's all about IGP and L2 VPN BGP address family. So leaf configuration is a little bit involved. So I'm going to show you IP VRF first. As you can see, we have a campus VRF configured, and there is a couple of interfaces aligned to that. All right. Let's look at show run. That will be easy. So you can see we have our VRF configuration with RD and RTs. There you can see that we have two RTs, two type of RTs, because we are saying stitching. And this is actually interesting. It help you redistribute route from BGP to EVPN domain and vice versa. So we have our VRF configured. Then this is regular configuration like IP routing and IP multicast routing. That's what you need. Please look at this L2 VPN, and we are choosing replication type static, that is the multicast replication. Then we are configuring our L2 VNID, that is L2 VPN EVPN. We are instance ID, and we are saying it is a VLAN base. Give it a encapsulation VXLAN. We are doing the same thing for 180 encapsulation VXLAN. Then we have some certificate information. You can safely ignore that. Please mind it that for EVPN configuration, you need to have network advantage add-on DNA advantage license. So if you are at network essential, you won't be able to configure any L2 VPN EVPN configuration, or you cannot go to that config prompt. So make sure you have the license. Then here we are doing our L2 VNI configuration. You can see we have VLAN configuration 110, and we are mapping or making it part of L2 VNID. And this is, sorry about that, this is actually configuration for L3 VNI, because 110 is our L3. So we are picking up one VLAN and making it part of VNI, assigning it to a VNI. However, for L2 VNID, you can see we are saying member EVPN instance 120 and mapping this VNI to the VLAN. So there is a VLAN to global VNID mapping is happening here. We have a loopback interface, and then we have the dynamic Anycast gateway. As you can see, we have VLAN 120 with a virtual MAC address, and the first IP address is your gateway address. It is assigned to a VRF, uh, which is campus in our case. So we have two networks, VLAN 120 and VLAN 180. Also, interface VLAN 110. Since you know VLAN 110 is our L3 VNID, we have that SVI for that. We are assigning it to VRF interface, but there is no virtual MAC or Anycast gateway kind of configuration here. Okay. Finally, you can see we have our NVE interface, network virtualization endpoint interface, and we are mapping our layer 2 VNID and layer 3 VNID to NVE, or we are parking it under this, so that all the bridging and routing discussion decisions can happen using NVE. It serves as a VTEC. So that's how simple is the configuration. Now time for validation. So let me show you the validation from the scratch. First, let's see what is the locally connected network or host we have. For that, we are going to use show device tracking database, and you can see we have one device which is we are learning from via ARP 10.10.120.11 on interface gigabit 103. And if I show you that configuration for that interface, it's a simply an access interface, and we have parked it in VLAN 120. So we have a host connected to this interface, part of VLAN 120, and it has an IP address from that subnet, and hence we can see the ARP coming in. All right. So that's the locally connected host. And when the switch learn about this locally connected host, it informed the EVPN manager. So that information goes to EVPN, L2 VPN, EVPN system manager. Here you can see EVI 120. So that goes to EVPN manager, and EVPN manager kind of like a build construct around it. So you have now EVI, you have L2 VNID associated to that, and all those things, and where it is connected. So it is connected to 103 and colon 120, that is my VLAN. You can also see summary. So here you can see we have L2 VPN EVPN. There are two VLANs, BGP ASN number, and this is my router ID. You can see we have how many MAC addresses and all those things. You can also have the RT and RD information here. Okay, so that's how the information gets populated to EVPN manager. EVPN manager will in turn inform the L2 rib, and L2 rib is a intermediary between the EVPN manager and the BGP EVPN system. So let's look at L2 route EVPN, EVI, MAC topology. Let's look at 120. As you can see here, it is building a topology. So we have this MAC address, which is our locally connected host, and you can see who is producing this entry. L2 VPN process. That means it's learned locally, and as you can see from next hop, this is the next hop. It's directly connected versus the another MAC address that is being learned via BGP. So we have another host somewhere in the fabric domain that we are learning via BGP, and that is my next hop. So where it lives at next hop 172.168.255.12, which is my leaf 2, and it is using a label 10.120. So that is my L2 VNID. So this information comes here, the local information comes here, and then it get passed on to BGP EVPN process, and BGP EVPN process in turn advertise it to the other peers or neighbors as a form of L2 VPN address family NLRI. So let's look at what we have here. Show BGP L2 VPN EVPN, and here you can say the MAC address, so or the IP address. So we can go back and look at this, our dynamic ARP. You can see we have this 11, which is directly connected. So show BGP L2 VPN EVPN, and then you can have the prefix directly, or you can also do detail, but detail is going to be very verbose. So let's start with summary. You can see we have two neighbors and we are learning some prefixes. Let's look at one of the prefix that we know we have. As you can see, this is a local prefix. That means we learned from 000 all 0, that is ourselves, and it is part of VRF campus. This is our L3 VNI, and this is our local router MAC look like, and also the VTEP IP address, that is the local interface itself. Now let's pick up another IP address that we know we are learning, but it is on different switch. So here you can see we have two entries for that. We have two available and one is best. You can see we are learning from .12, that is leaf 2, and you can see all sort of other information like what is the RT and RD looks like, and all those things you can see from here. Okay, however, the key thing what you need to focus is this line, the first line, BGP routing table entry, because this is how it is advertised. You can see the first is number 2, which is denoting EVPN route type 2. That is a MAC address information, and this is a MAC address for that, and this is the IP address. So that's the NLRI it is advertising, and we are receiving it from both the spines, and hence we have two routes here, all the labels, etc. So that's how this is being advertised. It go to the other side, and other side, when we go to leaf 2, now let's go to leaf 2. if I happen to come here and do show IP route VRF campus, you can see we have this remote end host IP address as /32 entry coming from leaf 1, and this is installed as BGP route because BGP address family L2 VPN EVPN is advertising this as a NLRI, and that is being imported here as BGP route. With that, let's do some verification. So I'm going to show you we have server 0 and we have server 1. So let's go to server 1. Here you can see we have an IP address of 180.12. So that is another network, IoT network. From IoT network, we want to ping 120.11, which is my employee on leaf 1, and this is on leaf 2. So let's see if we can do that. As you can see, we can reach leaf 1 employee network via from source IoT network. So that is possible, and we are doing routing or L3 we need for that. Let's also do one quick test. From server 0, we want to go to server 2, which is where they both are in the same VLAN. So let's try to do that. And with that, we can prove that the bridging is also working. We have an IP address of 10.10.120.11. So let's try to ping 10.10.120.12. This is the prefix. My leaf 1 is learning via L2 VPN address family, and we can reach. So as you can see, this is pretty straightforward and easy to build, and it's very scalable as well. So now, second part of our demo is we are going to configure border leaf so that for overlay construct so that we can make it part of fabric. For that, let me log into border leaf. So with that, neighbor, we have neighborship, summary, and we have the BGP peering as well. What we don't have is any kind of overlay configuration. So let me show you that real quick. As you can see, we have the VRF configuration here. That's the only piece. Then we do not have any kind of L2 VPN, VNI, L3 VNI, or NVE configuration here. So what I'm going to do next is bring in those construct. And as you can see, the configuration in EVPN is very much repeating. So you are pretty much doing the same configuration on each leaf. So it's called consistent configuration. So it's very easy. You can automate it as well. So let's bring in all the VLAN. So we need VLAN 110, 120, 180. Let me park it here. We have VRF information already configured. We are going to configure L2 rep VPN multicast replication. That's the construct one. Then we are going to do L2 VNI configuration, and we will configure both L2 VNI 120 and 180. Then we are going to configure L3 VNI, which is mapped to VLAN A 110, right? And finally, we are going to configure Anycast gateway, and we'll configure both the Anycast gateway 120 and 180 so that we can add all kind of host here. This is the first one, 120. Then let's go ahead and do 180. And finally, we want to configure our NVE interface. With that, we have our L2 VNAD, L3 VNAD, and NVE configured. Now, time to configure our host so that we can learn some MAC addresses. So for that, I'm going to go to server 2 and assign an IP address. Server 3 actually. Server 3 is not started. Let me start that. And while we are waiting for this to come up, we can actually go to our leaf and configure the interface as an access interface. As you can see, we have 104 that is connected to ETH0 server 3. So let's go ahead and configure that. And let's do VLAN 180 in this case. That's it. Now let me access server 3 console. And it's always best to access server via VNC. As you can see, this is a tiny Linux. And what we are going to do, we are going to configure IP address because right now there is no IP address on this. So we are going to do ifconfig, and this is ETH0 10.10.180.13 netmask. Of course, you need a sudo for privileges. With that, the IP address is up. However, you need to add a route as well. That's better. And Once again, we need to do this with sudo. Let's confirm one more time the IP address. As you can see, we have the right IP address configured, and from here on, let's ping all other end host in VLAN 180 and VLAN 120. So we know that we have another host connected to leaf 2, which is 180.12. And as you can see, we have the reachability, that is the layer 2 bridging. And we cannot reach 12. So that's interesting. Let's go and see what's going on. So for that, let's first see show NVE peer. Do we have peering? Yes, we have peering. And this is up. So you can see our VLAN 110 is up, but VLAN 110 line protocol is down because hundred and ten. Let's go ahead and say no auto state. VLAN 110. Just like on all your DAGs, say no auto state here, and that will take VLAN 110 go up so that L2 EVPN topology is updated. And now if we go to server 3, we should see within a moment we should be able to reach the other subnet. Our IGP has loaded because we are doing some aggressive BFD tracking. That's why the neighborship goes down sometime. As soon as the neighborship is established, yes, you can see from 180 server 3, we can start reaching 120.12. So that established our routing part.